let's see. Domain and function notation. Yeah, so this is kind of where we were at. And I think we had looked at some of these examples. I don't think we got to part E of this. I think part C may have been the extent of how far we made it on this example. Okay. So just to kind of refresh your memories, you have to look at which function is being used, right? So if they're talking about function f, you need to go find what the definition of function f is. If they're talking about function g, you need to go find what the definition of function g is. And as I had mentioned last time, whatever is given to you in the parentheses here is what's replacing the x variable in the function, right? So we saw with part B, since this was given as a plus 1 in function g, wherever you see x, you replace it with a plus 1, right? And that's of course going to be true for any of the function notations that you're working with. So how about we pick a couple examples from MyMathLab, since we had done the handout last time, and do some examples from. So let's take a look at this guy. Can you see that? Yes. So again, you will see this one is given to us in the set of ordered pairs. So you're given, how many is that? 3 ordered pairs, and they're asking you to find f of 6. So for f of 6, and remember that is basically asking you to find the y value when x equals 6. So what's going to be the answer for f of 6 here? 8, very nice. So you go find the ordered pair where your x value is 6, and you see what's its pair, right? What's the y value, and that's going to be 8. So this guy here is going to be 8, and that's going to be an answer. Yeah, Daniela, very nice. Again, this was a very basic example, but let's work. Okay, so this is going backwards. Now, this is asking you, f of x is 7. So not x is 7, the value of f of x is 7, which again, remember that means we're talking about the y value being 7, and we're asking you to find its corresponding x. So what is that going to be? Yeah, very good. So this time we go and find the ordered pair where the y value is 7. And that's of course this guy, and you can see the corresponding x value on that is going to be 2. All right, wonderful. So just, getting used to working in either direction. If they're trying to find x or they're trying to find y, we should be able to recognize those. Okay, perfect. So let's check this guy. And he looks good. Now, this is a set of ordered pairs, right? And we saw they will also give it to you in equation form. So what will that look like? So this is a combination of set of ordered pairs and the equation. So F is defined as a set of ordered pairs, and G is defined as an equation. You can also write that as G of X equals 9x plus 7. Okay? Now they're asking you to find F of 4 added with G of 4. So let's do those separately and then we'll add them together. So let's start out by finding F of 4 individually and G of 4. So what is our F of 4 value? Yeah, this time the X value is 4, which means its corresponding Y value is going to be 6. And for G of 4, guys, what do we do? Okay, so what are we writing in? Perfect. Yeah, so in this equation here, you're basically replacing your x value with 4, right? And then we simplify. So 9 times 4 plus 7 will give us what? Say that again?
So what? Oh,
Thank you. Sheesh, where did that math come from?
yeah, I'm done today.
Okay. 9 times 4 is 36, right? 36 plus 7 is 43. You know, every math teacher loves to hear that I'm done for today. Now, no, my brain's not ready for math. Tell me about it. We normally offer this class at 11:15. This semester just ended up being a different schedule. All right, guys, so we found f of 4, we found g of 4. Now we can combine that. So f of 4 was 6, g of 4 was 43, and do not give me 13 as the answer, people. What's our answer here? Very nice, 49. And you know, we did do a lot of similar examples like this from our handout, but this just again gives you a little bit of a refresher from last time. So let's go ahead, check our math here. 49. That looks good. Okay. So let's change this up a little bit and see what we got. All right, so yeah, this is kind of what I wanted to show you. What happens if they give you something more than numbers in your function notation? So this time they're asking you to find g of the quantity p plus 3. So p plus 3, that entire thing is replacing your x. Okay, so make sure you're putting that whole binomial, the p plus 3, when you do this. So the way I would go about writing this out, you can see we're basically replacing all the x values in the original function. So we have 3 times x squared plus 3 times x plus 3. So you can see wherever we need to put the value for x, I'm leaving it as blank, so that when I make my substitution, I'll remember we need to be replacing this guy with p plus 3 and p plus 3, right? And then we can go ahead and expand. So the first thing I would suggest us doing is obviously, let's do FOIL for the p plus 3 quantity squared. So that's p plus 3 squared, which is obviously p plus 3 multiplied into itself. So when you do FOIL on that, what will we end up getting? So FOIL, remember, first, outer, inner, last.
Plus 6p plus 9.
Very good. Yeah, so p squared from the first, then you are doing 3p plus 3p, which will add up to 6p. And then 3 times 3 will give you 9. And you know, the simplest rule about working with FOIL is, especially if you're multiplying the same term with itself, for the middle term, you add those constant terms, right? 3 and 3 will give us 6, so that ends up giving you 6p for the middle term. And then for the last term, you multiply 3 times 3, which ends up giving you 9. And of course, the leading term is going to be p times p, which is where your p squared comes from. So let's go ahead and put that in our equation here now. So remember, you still have that 3 on the outside. The result of our FOIL gave us p squared plus 6p plus 9. Plus, and this time you can go ahead and multiply the middle term. So you need to distribute that 3 inside the parentheses, which will end up giving us 3p plus 3 times 3 is 9. And then that constant 3 at the end, you need to bring that back down as well. And then, of course, we will now need to multiply the leading term, that 3, with our FOIL product. So we'll need to distribute that 3 in the front, which will end up giving us 3p squared plus 6 3s are 18, so that will end up becoming 18p plus 3 times 9 is 27, so bring that guy. And then the remaining terms will come down as it is, so the 3p plus 9 plus 3, which I guess you could have added those guys. Okay, combine like terms, simplify this. Daniel, put your phone away. When we combine like terms, what do we get? And what are the like terms here? Because of course, 3p squared didn't have anybody to be added to. What else did we? Which will give us, very good, and
Seven. Just, 30.
that, so yeah, 18 plus 3, what did we say, 21 p? Then let's see, what did you say for 27 and 9 and 3? 39, yeah. I mean, I'm kind of thinking 27 plus 3 gives us 30, 30 plus 9 gives us 39, but of course you guys can just dump all that in calculator. And that's it. That's going to be our final answer. Once you have made all those, calculations happen. So let's plug this guy in, see what we got. Plus 1 plus 30. Check that. So really, it's just about being careful in plugging in the numbers correctly, right? And you're keeping track of your multiplication and in this case, addition. Any questions on this? Daniela, Danny online, any questions on this? No? Okay. Let's go over and see what we have. Okay, so this is kind of what we were building up to last time. And we of course didn't get to finish it. So as you can see, we had done part C over here, which was finding out what f of x plus h would be. Part E was where they were having you do the subtraction. So once you found the f of x plus h function, then you subtracted the original f of x function for it. And the last thing you do is division by h. So let's use this example to help us out with that. So I'm gonna actually break it up into 3 parts because I find it is easier to work that way. So for part 1, we are going to find what f of x plus h will come out. For part 2, we will do the subtraction. So once you have found part 1, then you can subtract the original function f of x. And then part 3 is whatever answer we get from step 2, we're basically going to divide that by h. The last part would be taking the answer from step 2 and dividing it by h. Okay, so let's take a look at step 1. And this one is using a fairly simple function, so that's kind of nice. They are using 25x. So first thing we're going to do is replace our x with x plus h. So that will become 25 times x and replace the x with x plus h. So as you can see, it literally means you're just going to distribute that 25 inside the parentheses, right? Which will end up giving us 25 times x plus 25 times h. Okay so far? Yeah? All right, next step, part 2 is the subtraction. So this is where we're now going to take the answer from step 1, and from that function, we're going to subtract the original function. So I'm going to use brackets here just to separate the 2 functions for now. So f of x plus h is what we just found out in part 1. So that's 25x plus 25h. And then from that, we are subtracting the original function, which of course happens to be f of x equals 25x. Okay. And then of course, we want to clean this up. So the first part I can write down as it is 25x plus 25h minus, so of course we know that minus sign is going to make the second part of our equation negative. So that's going to become minus 25x. Anything we can combine together? Yeah, you have a positive 25x and a negative 25x, right? So they will actually cancel each other out and we are left behind with just 25h. Okay, so step 2 is done. Step 3, the last part, can you guys see that? Yeah. The last part was taking our answer from step 2 and dividing it by age. So that means we were left with 25 age in our step 2. When you divide that by age, you will see H and H cancel each other out, leaving you with just 25, and that is your final answer for this difference quotient. Now, difference quotient is actually a calculation for slope. So what you have essentially done here is found the slope of this function. Now, when we think about slope, we usually think about slope in terms of straight lines, but you can actually find slope on, non-straight lines, on curved lines. And this is actually something, if you guys have to take calculus, this is kind of one of the first lessons they teach you in calculus, is what they call as average rate of change. We call it slope in simple algebraic terms, also known as derivatives when you get to a calculus course. So this one here is basically asking you, what is the slope of this line? And this equation is given to you in the mx plus b format. So of course, we know our slope is going to be that coefficient of x. So, that's what we proved. We came up with 25 as our answer. Alrighty, let's plug him in. Number 5, check that, and it's good. Of course, your functions will get a little bit more complicated than the ones we saw. So, maybe something like this guy here. Negative 10x squared plus 7x plus 9. Daniela and Danny, are you guys able to see the whiteboard? It's blank right now, but are you able to see it? Yes, okay, wonderful. All right, guys, so our function is x equals negative 10x squared plus 7x plus 9. Yeah, okay, so step 1 is finding the f of x plus h function. So everywhere that we see an x, we are going to replace it with x plus h. So that means you will have negative 10 in the front, replacing the x. So that gives you the, keeping it blank for now, so minus 10x squared plus 7x plus 9. Okay, so wherever I have the blank, I will replace it with x plus h and x plus h. Now again, you will need to do FOIL on that first x plus h squared. So we have negative 10 in the front, and the FOIL will end up giving us x squared plus 2xh plus h squared, and I'll show you that in a second, in case you're not sure how we came up with that FOIL. And then, of course, for the middle term, remember you need to distribute that 7 inside the parentheses. So that will be 7 times x plus 7 times h plus 9. Let's talk about that FOIL. So you're multiplying x plus h with x plus h. So of course, you're going to end up doing x times x. You're going to do x times h Middle term, same thing, you're multiplying h and x, so I'm just gonna keep it in the same order, x times h. And then our last one is h times h, which will give you 8 squared. So again, those two middle terms are the same terms. So that's x plus h added with x plus h, and they of course add to 2x. Okay, so that's how that guy comes out to be. Now, the last thing we need to do before we can wrap up step one is distribute this -10 inside our parentheses and then combine whatever like terms we can. Side, so let's see, that will end up giving us -10x squared. -10 times +2 will give us -20 x times h. -10h squared. And plus 7x plus 7h. Plus that. Anything in there that looks like terms, you've got x squared, you've got xh, h squared, just x, just h, and a constant. No like terms, right? So you can see as the function becomes more involved, instead of a monomial, like 25x, this is a trinomial, -10x squared plus 7x plus 9. You can see those f of x plus h will end up becoming larger functions. Alrighty, so we took care of step one. Now let's do step two, which is where we do subtraction, and you want to keep things a little organized. I'm just going to change the on my step two. So this is where you take f of x plus h, and from that you subtract the original function f of x. Okay? So this whole big answer we got in step one, I'm going to put that in brackets for now. -10x squared minus 20xh minus 10h squared plus 7x plus 7h plus 9, all of that in brackets. From that, we are subtracting the original f of x term. So I'm going to put that in bracket again for now. And my original function was -10x squared plus 7x plus 9. Now you have to remember the reason why we're using brackets here is because we do have a minus sign here. And this minus sign will need to be distributed inside that second set of brackets. Okay. So. Alrighty, let's take a look here. So we now have, I can bring those first terms out as it is, -10x squared minus 20xh minus 10h squared plus 7x plus 7h plus 9. And then once I do my subtraction, I'm going to put those terms next. And I'm going to try and put them under like terms so that it'll be easy for us to cancel out. So here you will see we will need to do negative times -10x squared in the second set of parentheses. I don't know if you can see. My mouse to move, yeah. So we're multiplying -10 with a negative with -10, which will end up giving us +10x squared. So I'm going to put him underneath, the like term. Then we are taking the negative and multiplying it with +7x. So negative times positive will give us negative. So that -7x will go here. Same thing's going to happen with the 9. Negative times +9 will give us -9. So that will end up winning. So when you combine all of these guys together, those like terms will cancel each other out. So -10x squared, +10x squared cancels out. +7x, -7x cancels out. +9, negative. Leaving us, and this is where I had kind of told you last time also, you should have every term that's left behind with an x inside it. So you will see we are now left behind with -20xh minus 10h squared plus 7h. Each of these terms has an h on it, which is good because our third step is dividing by h, right? So you can see each of those terms will use an h. This was step 2. I guess I'll need to add new word here. Right, step 3 is where we take the answer from step 2. and divide it by h. So we had negative 20 h negative 10 squared. Mm, So this is the answer from step 2, divide everything by h, or what I like to do is separate. So divide the first term by h, divide the second term by h, divide the third term. by h. So it makes it easy to see how those h's cancel each other, right? So in the first one, of course, h and h will cancel out. Second one, only one of the h's cancel out, one will stay. Third one, of course, again, the h and h will cancel out. Leaving us with negative 20x. You okay back there? Yeah? Negative 20x because the h canceled out. Minus 10h. And you will see when I cancel that middle term, I'm canceling out the square, not the h, because I don't want us to get confused that the h canceled out. Because remember, only one of those h's cancels out. So you have negative 10h left behind. So please be careful about that. Plus 7. This is going to be your final answer. Now, remember how I talked about in our previous example that this actually gives you the slope of your line. Now, if you know negative 10x squared, what was it, plus 7h plus, sorry, 7x plus 9 is actually a parabola. So we know it's not a straight line. It's not going to have a constant slope. So what happens is as you move along that parabola, your slope is going to change depending on what part you are at. But what this function here tells us that if you just put in the value of x and h is by how much you're moving. So are you going, 0.1 distance between x and the next value, or are you going 1 whole unit, or are you going 10 units? So the h is actually that distance between your two x values. But once you know that, you can find the slope anywhere on this original function of f of x. And that's kind of one of the things, like I said, you talk about in a calculus course. So what we are doing is just showing you that basic math, but you will get more detail if you need to take a calc course. Alrighty, guys, so let's plug this into our answer. So negative 20x minus 10h plus 7. And you guys can probably not see that right now, but I'll show you that in a minute. But before we go back to the MyMathLab screen, questions on this example, these 3 steps. Be patient. Don't try to rush through this because, if you rush through and you make an error, then that's obviously when you get in trouble. All right. Let's go back to MyMathLab. There we go. There's your answer. So let's check and see if we did this correctly or not. All right. That's it. All right, so now that you've seen the calculation, you can kind of see the explanation over here. So I know our average rate of change at the slope formula looks a little bit different than the function we just looked at, but basically it's the same formula. Okay. So when I'm saying f of x plus h minus f of x over h, well, your f of x represents the original y1 value, because that's where we started at. Then you move, maybe horizontally or diagonally a little bit on your graph. So the f of x plus h is actually going to represent the y2 value. So from the original point, how far have you moved? And of course, remember, if you're moving along the graph, you're moving horizontally and vertically. So the f of x plus h and f of x is showing you the difference in the y values. And the h is basically the denominator, the distance between the two x values. So yeah, it looks like a different formula, but essentially it's a rewritten slope formula. That's what the difference quotient is. Now you will see there is examples, like that word problem here, just kind of showing you how the average rate of change would work in an application. So again, you can find that in your spring 2020 lectures if you wanted to look at it. You can kind of see they did a little bit of a graphical explanation of how the difference quotient works. So you can see our two ordered pairs are going to be x comma f of x, and then x plus h, because you've moved horizontally a little bit distance and its corresponding y value. So what happens here, of course, you're doing y1 here, y2 here, x1 here, x2 here. Additionally, what's happening with this is if you just again use the slope formula, I'm kind of showing you that in here. Of course, my y2 is now f of x plus h, y1 is f of x. So that literally translates the same way. Now, for the bottom, you would be doing x2 minus x1, so that's x plus h minus x, and you can see my x and negative x will cancel each other out, leaving you with just the h value. So like I said, it's the same formula, just written a little bit differently, and that's what a difference quotient is. It's helping you find the slope at a given distance over your graph at a specific place in your graph where it's helping you find that slope. And then again, you'll see several examples in the handout as well if you guys just needed some extra practice. But that was the last thing we did in 2.1, so let's move on to 2. We're going into the graphs for 2.2. So this one here is talking about, of course, it's very easy to do a straight line. You basically need 2 points, and we saw several different examples of that in chapter 1. We actually also talked about how to graph a circle in chapter 1. With other equations, we may or may not recognize their shape. So sometimes, it's a good idea to kind of do several ordered pairs so that, we can kind of get a sense, of what the shape would look like, and then you're connecting the dots in a way. Now, of course, we have technology to help us with a lot of the graphing, but I just want to show you maybe an example or two on how we would do the ordered pairs, and then we'll of course use technology to help us out. So here they're asking you to graph a basic square function. You have y equals x squared, and then they're asking us to find out if it's a relation or if it's a function, and then of course what the domain and range will be. So if we talk about, finding our ordered pairs here, you have y equals x squared. So we can choose simple x values, and a lot of times my go-to x values are actually pretty simple. I keep it at -1, -2 on the negative side, and then 0, +1, +2 on the positive side. So you're literally saying, okay, if x equals -2, what is my y value going to be? And that's going to be taking our function x squared. So replace the x with -2, and of course, negative times negative is positive. And if you don't have we can do that with all of our x values. If x is -1, same thing for the y value, replace -1 in the function. -1 times -1 is +1. We know if x is 0, that's going to be 0 squared, which of course will again come out to be 0. And you can replicate that for the +1 and +2 numbers as well. You see those guys will come out to be 1 and 4. So once we have that. Yeah. So let's see that. If I take my ordered pair 0, 0, that's gonna be at the origin. Positive 1, positive 1. 2, 1, and 4, this will be negative 1, positive 1, and then of course negative 2. So let's see, 1, 1, 2 and 4, negative 1, 1, negative 2 and 4. That's kind of the general shape, which actually tells us this is gonna come out looking like a parabola, which is what it is, right? And that's kind of the general idea, right? We find enough pairs and then we base our graph off of that. So is this guy a function or is it a relation? And remember, for function, we said for the same x value, you cannot have 2 different y values. Or remember, we had done the vertical line test initially. So based on any of those things, what do you say? Is this guy a function or not? Yeah, it is a function. Very good. So yes, he is a function. Now, what can you tell me about the domain and range for this function or equation? Domain is all the possible x values that we can use. Range is all the possible y values that they come. So what kind of x values can we use for the x variable in our function?
Constant and negative.
Yeah, no restrictions. You are going to use all real numbers. So your domain is going to be from negative to positive infinity. And you know, think about it with the graph. Let's see if I. There we go. So this arm of our graph, you know, it's going up, but it's also going towards the right-hand side. So basically the idea is as your x values will increase, your y value will also increase. So as x goes towards positive infinity, that y value is headed upwards, right? Which is also positive infinity on the y-axis. On the left-hand side, as this arm of our graph is going left, he's obviously also headed upwards. So as this side of my arm goes towards negative infinity, you know, the x values are getting smaller. But because of that square, we know all the numbers end up becoming positive, right? Which means your y value is going to go up towards positive infinity. So what does that tell us about the range, the y values?
It'll be 0 and positive infinity.
0 to positive infinity, okay? And then the question is, are we including 0 in our set or not?
Yes, because it's one of the y values.
Perfect, perfect, very good. Yes, you are including it, right? So you put a bracket on that 0. Questions? Save this guy real quick. And how about we go to our friend? Presence. And, you know, again, just zoom out so you can kind of see what that graph is doing. Now, of course, the more we zoom out, it's going to start looking like a straight line, so I don't want to zoom out too much. But obviously, you can see it's increasing as those arms are also heading outwards, and you can verify, you know, what the shape of your graph is going to look like. Now, in MyMathLab, this is kind of what, you know, the equation or a question might look like. So we'll come back to this guy. Let me just show you a couple more examples here in the handout. You've got the square root function. Now we know there's restrictions with square roots, right? What's the restriction for this guy with the square root of x? What numbers can we use for x and what numbers I guess we cannot use for x? Can it include 0 or no?
Square root of 0 is just 0. Right.
So,
Yeah.
yes, yeah. So in this case, anytime, and this is true, remember, for any even root, so square root, fourth root, sixth root, your x value can be greater or equal to zero, but it cannot be a negative, right? So you can start with zero and anything greater than that, but nothing smaller. So that actually tells you your domain would start at zero, and you can keep going to positive infinity. For ordered pairs, you need to again start at zero, so you can do 0, 1. Since it's a square root, I'd probably use perfect square numbers, so I may actually do 4 and 9 for my x value instead of using like 2, 3, because they're gonna give us decimal answers. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So you can use that as your ordered pairs. And then you can see 0, 0 again is at the origin. You had 1, 1. 1, 2, 3, 4, and 2, 9, and 3. So this is kind of what your graph ends up looking like. Yeah, unfortunately, this classroom does not have Power Plus, near the tables. We've been asking for it, but we just never seem to get it. So what kind of graph does that look if you had to go for the shape of it? What would you say? What does it look? No, not recognizing the shape. All right, we'll come back to that question. Is it a function? Yes or no? Yes, because it will pass the vertical line test, right? And of course, we can see for the same x, we're not really going to end up with the same, same x with different y values. What do you say about the range? What kind of y values are we coming up with this function? Yeah, because again, you can see there's no graph on the negative side of the y-axis. I mean, we're starting at 0, and of course, we're headed upward. So the range is also going to be from 0 to infinity. Daniela, Danny on Zoom, did you guys have any questions on this? Daniela, you're okay, all righty? Let's see. Let's go to Desmos again. What if I do? So what do you notice between the two functions that I just graphed? Does this guy look like a function? What you're seeing on your screen right now? Yeah?
Yeah.
And I'm seeing a lot of you nodding. This is not a function, guys. It's gonna fail the vertical line test. Daniela, yes, very nice. This is not a function because if I were to draw a vertical line, it's going to cross the graph at 2 points. This function in green is the x equals y squared function. It's a relation, sorry, not a function. It's a relation, but not a function. If I remove that second graph, yes, I do have a function now because I'm only seeing one arm. It's actually, the original function is x equals y squared, but what you are seeing is 1/2 of that. So you can see if I did square root of x and negative square root of x, together they make the x equals y squared function, but each one individually is a function, right? Together it's a relation, but if I separate the upper arm and the lower arm, each one individually becomes a function. So that's kind of what's happening over here. That's what you have, a function, and it's a parabola on its side, and you're just seeing one arm, the upper arm of that parabola. That's your square root function. Right? Let's figure this guy's out. Let's see what we have next. So you can see this is what I was talking about, a parabola opening to its right. And of course, this guy is not gonna be a function. Just after looking at the square root function, what would you say about this guy, the cube root? Any idea what this graph might look like?
Same, just working.
That's not really a description. All right, let's find out what it's going to look like. We'll start by creating our x and y table. So y equals cube root of x. Now remember, the restriction of 0 and greater than 0 is only for the even functions, square root, fourth root, sixth root. So there's actually no restrictions on a cube root function. So your domain is going to be all real numbers. If you want to work with happy numbers, find something that's a perfect cube, right? So what's a perfect cube number? Very good. Well, thankfully, 0 and 1 are always happy numbers. But the others going higher would be your 8, -8. What would be next after that?
That one, so
Yeah, 27. So 0, 0, +1, +1, -1, -1, 8 becomes 2, -8 becomes -2. So you know, think about it, go backwards, right? 1 to the third power is 1, so cube root of 1 is gonna be 2 to the third power is 8, so cube root of 8 is going to be 2. 3 to the third power is 27, so cube root of 27 is going to be 3. So you can kind of do the calculation backwards. So this guy is end up going to looking like 0, 0, +1, +1, -1, -1, +8, +2, -8, -2. So it kind of looks like a very lazy S shape. He's taking his own sweet time, figuring out it's an S shape. So I already said domain was negative to positive infinity. What will be the range? Y values. Like look at that arm going to the right-hand side, there's the other arm going to the left-hand side. So where are they headed on the y-axis? So as this arm here is going to the right on the y-axis, where is he headed? Upwards, downwards? Up, yeah. I mean, he's making a slow trek, but it is eventually going to end upwards, which means he's headed towards positive infinity on this side. On the left-hand side, as you are going to negative infinity on the x value, where are you headed on the y value? Yeah, you're headed down, so you're going to negative infinity there. So yeah, same domain and range for this guy. The range is also negative to positive. Can we call this guy a function, or is it just a relation? It's a function, yeah. So that's a yes on the function. Okay, let's save him. And just so you're not traumatized by my graph, let's put it in this.
Wait, on the bottom, it had an N and then the real.
Did it?
Yeah, very, very bottom.
yeah.
Skip right over it.
Yeah, it was.
There we go. Thank you for paying attention. I'd lie and say that was a test, but it really wasn't a test. I wasn't paying attention. So that's a better looking graph, right? And like I said, you guys can zoom out just to see where those arms are headed. And you can see, as I said, it's making a slow trek, but it is eventually, start getting to y on the positive infinity side and y on the negative infinity side. Alrighty, beautiful. Okay, so that's your cube root. Now, of course, when we were talking about the vertical line test, we had talked about any kind of circular oval shape, which is not going to be a function, but just like we saw with the square root of x and negative square root of x function, if you were to separate this and just look at the upper semicircle, that's a function. If you just look at the bottom half, the lower semicircle, it is a function. So if you separate the top and the bottom halves, you can create functions out of a circle also, and that's kind of what we're talking about here. So remember the general equation for a circle was this: if you are centered at the origin at 0, 0, or if you are centered away from 0, 0, then the equation goes like this. We actually have the line. Squared equals r squared. So if you're centered at 0, 0, basically your h and k numbers are both 0, so that's why the equation comes down to this. So you will see when we are talking about what does the equation for the top semicircle and bottom semicircle looks like. The idea is, in this equation, get your y by itself on one side and move everything else to the other side, and you'll see I've shown you that math right down here. So this is our original function. Start by moving that x squared to the other side. So that's what we did. Bring that x squared here. So you end up getting y squared equals r squared minus x squared. Now, since that's a square, we would end up taking a square root. And anytime you take a square root, you end up with one positive, one negative root. So that's where that plus or minus is coming from. So the square and the square root cancel each other out, giving you r squared minus x squared inside a square root. If it's positive, it's going to be the top semicircle. If it's negative, it's going to be the bottom semicircle. So again, all of the equations are coming from that basic equation of a circle centered at 0, 0. Now in this examples here, they're not actually using examples where the center may not be at the origin at 0, 0. So they're not showing, what happens if you were, on the other side, which basically means these guys would just end up becoming x minus h. X minus h squared, but they're just keeping it simple. So that's what. So all you need to know if you're looking at a top or bottom is in front of the square root, do you see a negative sign or not? If there's no negative sign in front of the square root, that's a top semicircle, right? If there's a negative in front of the square root, it's a bottom semicircle. So look at number 5 over here. So is this a top or a bottom semicircle, number 5? Bottom. Bottom, please. Can you tell me what the radius is for this guy? Very good, because your r square is 16, so take the square root of 16, and that gives you your radius. So when you try to graph this guy, radius of 4, we're of course centered at 0, 0, so just go up 4 units. 3. 4, 4. This was what bottom semicircle 1, 2, 3, 4. Now this is a semicircle, so of course you're not going to have arms, going in each direction. Is just going to be between that -4, +4, -4. Right? Function, yes. Alrighty, and then let's talk about domain. Now remember, again, I said you do not have arms with arrows on them. So this is not something like a parabola that just keeps going. This is it. This is your graph. So based on that, what is your domain? What is your range? Domain is the x values, range is the y values. For domain or range?
Domain.
Okay, and then what kind of symbols are you putting on -4? Brackets or parentheses?
Brackets?
Very good, because yes, you are including the endpoint because these points are part of your graph. Very good. Alrighty, what about the range, the y values?
0 and -4.
Okay, so smaller number first.
Oh,
So -4, 0, and same question to you, brackets or parentheses?
so
Brackets, yes, you are including percentages. Right, so these guys are not going towards infinity like those other graphs. That's the only difference that's gonna happen with something like, a contained shape. That's a closed graph, not an open graph. Right, good job, guys, very nice. So that was a bottom semi, so it will pretty much be the same if you had an upper half. Which is kind of what number 6 is looking here. And then piecewise functional. Now, just to show you, Desmos what these graphs would look like, we would have y equals and then we have negative square root of 16 minus x squared. Ooh. So none of it, so we can see that. Check the board. You can see that's what the graph is.
forget the function you typed in.
Right. So just like it was given in our handout. All right, let's take a look at this fellow here from our math. So you are given y equals 6 minus 2x squared. Now, of course, we can see this is a second degree polynomial, so we know it's got to be a parabola. But let's see what kind of parabola we are going to have. So you can see they're already giving you the x values here. We just have to find their y values. So that's going to be 6 minus 2. Instead of x, we'll use -2. Can you tell me what that y value will come out to be? 6 minus 2 and then -2 squared in the parentheses. And of course, you will use, please excuse my dear and Sally, to solve this, or again, throw it in your calculator, whatever you guys like. For the, well, since you're doing -2 squared, the two negatives will become positive. Okay, and then for the final answer, yeah, because then you multiply, right? Subtraction after multiplication. So first you multiply. So 2 times 4 is 8, 6 minus 8 will of course give you -2. So let's plug that down in. Now, you will need to complete the table, so you won't be able to check the answer until you finish that whole table. So let's go ahead and do the other 4 values. So 6 minus 2 times -1 squared, and what is he coming out to be? +1. All right, that will be 6 minus 2 times 1, which will be 6 minus 2. All right, what about next one with the 0? That should be pretty easy. 0. And then final answer? 0. Nope.
Oh, right.
Yeah, because you're doing 2 times 0, right? Which becomes a 0, but the 6 will stay. So simple little calculation, people, please, please, please be careful. Alrighty, what happens with +1 as your x value? Sure.
I mean, well, like, I'm saying like, normally. Cause that's not like that 1 times 1, I'm saying the answer is -4. That's not.
Check your math again.
It's 4. It's 4, same.
Because the square is making all negatives into positives and keeping positives positives, right? So it's actually 6 minus 2 times 1, which is 2, which will still end up giving you. So your number has to be larger than 6 before you will get into the negatives. And the last one, guys, for x equals 2, what do we got?
It's -2, 0.
So I heard both positive two and negative. Which one is it?
Positive.
You guys are not helping at all.
No,
It
it's
will
negative, it's
be
negative, it's
negative
negative.
because now you're going larger than 6, you're going to end up with 6 minus 8, which will end up giving you negative. And that's parabolas, right? We do see that kind of symmetry in parabolas. We're not quite at that point to talk about symmetry, but you will notice that. All right, I think we've got all 5 points in there, so let's check our table. Yep, looking good. What do they want us to do next? They want us to graph this guy. Let's get rid of these writings. Graph, determine the domain and range, and then y is a function of x. Okay, so let's start with the graph. Now, of course, you will need to select your. I kind of don't like that they call it that, but obviously the shape tells you it's a parabola. They're calling it a 3-point quadratic tool. So they want you to pick the 3 points and then graph your parabola. So let's see. Again, remember looking at the yellow strip on that right corner so you can see where your ordered pairs are going to be, if you're at the right point or not. So I'm going to use, I guess, -2 and -2 is one of my points. I don't know, I guess I'll do the middle one, 0, 6, he looks good. And then I guess I'll do the other one too, and +2 and -2. So get your 3 points there. Save, check your answer. Now, again, like I said, we're not quite at that point yet, but we are getting ready to talk about it. So that negative in front of the x square actually told us the graph would be opening down. The 6 is your y-intercept, and that's why we're crossing the graph at that point. So a lot of these things you can actually recognize from the equation itself. Those things kind of got verified with the graph. Domain for this function. So what kind of x values can we use for our parabola here? Where are those arms heading? No, because I know you cannot see it, but it's understood that these arms are going to keep.
It's just negative infinity.
Yeah, because again, and we can do this on our trusty friend. So, again, you can kind of zoom out and you will see those arms are going to keep going downwards, right? But that also means they are going to get wide, which means on the left-hand side, it's going to go towards negative infinity on the x-axis. On the right-hand side, it's going to go towards positive infinity.
So, not again, like, when you're finding the domain and the range, how do you identify if you're doing parentheses, if you're using parentheses or you're using brackets?
So brackets really only happens if you have something like a closed graph like we did with the semicircle. Or if one end, like in our square root function, how we started at the origin and that arm went to the right, but there was nothing else happening on the left. So that's kind of when it's going to be closed. So that's likely where you'll see the brackets. But if both sides of your graph are, continuing on, it's an open graph where the arms are going to keep going up or down or somewhere, then those ones are usually where you're headed towards infinity negative.
Okay, so you would close them with parentheses.
So close is with parentheses, open, close is with brackets, open is with parentheses.
So like an infinity is never gonna be in a bracket.
Never. And remember, we had kind of talked about how infinity technically is not a number, it's just a symbol that tells us you're growing really large or really small. So that's another reason why you never put brackets on infinity. So you're going from negative to positive infinity, and that's actually going to be true for all parabolas that open up or down. So if your parabola is opening up or opening down like this guy, your domain is always going to be negative to positive. If it's a parabola opening on the right or left, that's when it's going to change. Okay, so that might be also something to keep in mind. Okay, now I do want you to think about the range, because that's the Y value on this. And again, remember, it's not showing you here, but we know these arms are gonna keep going down.
So it would be 6 bracket negative infinity.
So again, good numbers, but put the smaller number first. So negative infinity is going to be smaller. So you are actually kind of starting at negative infinity and think of it as stopping at the highest point, which is that y-intercept, right? The 6. And this is kind of, again, Daniel, to answer your question, you can see our parabola stops at that 6 on the y-axis. There's nothing happening beyond it, right? So you will again use a bracket on the 6 because that's telling us we're basically stopping at 6 and we're not going to go any higher than a value of 6 on the y-axis. Okay, so that's going to be your range. Alrighty, let's put this guy in our little answer box here. So we are at negative infinity. And then into 6 to the left. A, B, C, or D. They want us to determine whether Y is a function of X or not. So A, B, C, or D. First, I would say narrow it down. Is this a function or not a function? So you know if you have to choose the yes or no option, and then you can choose between the 2 yeses or the 2 nos. So would we call this a function or not a function?
Okay.
Yes, so that leaves you between A and C. Okay, how many of you go with option A? A says, yes, it's a function because no vertical line crosses the function more than once. Yeah, but
Horizontal is up and down.
no, a horizontal would.
God damn it, dyslexia, I'm sorry.
And that's okay. We're talking vertical line test, right? Because the vertical line test helps us determine if it's a function or not. So yeah, it's gonna be option A. Let's check that and that looks good. Zoom people, did you have any questions on this? Daniela, Danny, are we doing okay? Okay, Danny, I think you said you are okay. Daniela, did you have any questions on this? Daniela is okay too. All right. Beautiful. Let's see. That gives you a little bit of an idea on how to do one of these examples in my math. Okay, so similar example, except they're not asking you to do the table and they're not asking you to actually draw the graph. They're asking you to select the right graph. Your function is x equals -4 cube root of y. So that -4 is the coefficient front of the cube root of y function. So this one actually is written backwards, right? Instead of y equals something, this is given to you as x equals. How do you select your graph? A, B, C, or D, what would you do to figure out what the graph for this is? Okay. Okay,
Said that before, but it was a different number. Make that y-intercept.
so this is not the y-intercept in this case because that has to be something that's being added or subtracted from your function. This one is as a coefficient, right? So that actually acts, and we'll talk about this in the next section. It actually acts as a stretch or a shrinking coefficient on your function, so not as an intercept. So still looking for like, how would you figure out what your graph is on this guy?
Anything's positive or negative in front of this curve root.
Okay, So we know from the previous example, usually negative means you're opening downwards, positive means you're opening upwards, but that's really, you can see from the four options, we're not really seeing specific downward, upward kind of thing.
So I view it as like, if you have a positive, if you get a positive, so if Y is positive, once you go through the cube root, you'll keep a positive. So you'll have a positive Y, you'll be on the first and the second quadrant. But when you multiply it by -4, it turns into a negative, so your x-axis, your x is gonna be on the negative. So you'll have a positive Y and a negative x when you, so basically, A and D are incorrect because you don't get a positive Y and get a positive X. So it's.
Okay. Okay, do you have something else you wanna say after that? Because I do wanna explain what you're talking
No, you can.
about. Okay, so what Daniel here is saying, let's take a look at our. Let's say we keep our Y positive, right? And we'll just keep it something simple. So let's say Y equals 1. So when you solve this, cube root of 1, of course, comes out to be 1. So this will end up giving you -4. So what he's saying is when your Y is positive, your X is actually going to be negative, and that happens in the second quadrant where your Y is a positive number and X is a negative number. So he's saying just by using that logic, you can see this space is blank over here, so that does not work. And this space is blank over here in second quadrant, so that does not. So he's kind of eliminating these two options because we wouldn't see a graph in there. So that actually leaves you with options B and C. And obviously you can see there's a distinction between the two shapes. So which one should we try? Daniela on Zoom is saying option B. What do you guys say?
I agree.
You agree with Daniela? All right, let's try, see what happens. All right, so we've got option B. Let's see if this can check that. All righty, nice. So we've got option B, that helped us. And I can enlarge that graph for you. So what's happening here, guys, is because of that negative sign, you are seeing the shape that you are. Now, if that was a +4 instead of a -4, this graph just flip it on its x-axis, just horizontally flip it, and that's what the graph would look like. So it's that difference of where your x and y values end up when you have that negative in front of your function. And like I said, we're going to talk about this in section 2.3, but let's continue from here. So now they want to know the range. What are your y values that you're going to have for this function? And again, I can enlarge that graph to help you guys out. So what would you say your range for this function is? Okay, and I know the next question is going to be domain. So what's the domain for this function? Same.
It doesn't look to be close.
No, it's definitely going to keep continuing in both directions. For sure. So yeah, as you can see, as this arm here is going down on the x-axis, it's going towards positive infinity because, of course, it's going to keep moving right also. And on the y-axis, it's going to negative infinity because he's headed downwards. This arm of our graph, as it goes up, it's also going left. So on the x-axis, it's headed towards negative infinity. On the y-axis, it's headed toward positive infinity. So yeah, your domain and range is going to be all real numbers, negative to positive infinity. So let's go ahead. Plug these numbers in. So again, we're going from negative infinity to positive infinity. Close, check that, looks good. Domain, same thing, I guess I could have copy and paste. And then is y a function of x? Yeah, yeah, it will pass the vertical line test, so it is a function. Let's say yes. We are good to go. Ready? This one here is about piecewise function, so before we do this, let's come back to it. So, when we talk about piecewise functions, the name itself is telling you it can be broken up into pieces, or it can behave differently over different pieces of the domain. So it just depends on what kind of function you're looking at. So this one here is talking about if two or more functions are pieced together, right, joined together, we call them piecewise functions in the simplest of terms. And one of the basic piecewise functions is actually your absolute value equation. Now, if you just do the graph of an absolute value equation, you can kind of see this is what it ends up looking like. So it may not look like it's in pieces. It kind of looks like a V, maybe a parabola is a U, this guy's a V. But this is actually a piecewise function because it's defined differently on either side of the X axis. And that is what we're kind of talking about over here. So we're basically saying if your X values are 0 or positive, the function is actually defined as Y equals X, and that gives us that straight line with a positive slope. If your X values are negative, then your function is actually defined as negative X. So Y equals negative X, which is a slope with a negative line. But we know with absolute value, positive stays positive, negatives becomes positive, right? So think about the second half over here. If your X was negative to begin with, and then we put a negative in front of that, two negatives end up becoming positive, right? So that's kind of how the piecewise function is held in defining what an absolute value function looks like. So we don't, like I said, normally think of absolute value as being a piecewise function, but it is because it's defined differently over the domain. So 0 to infinity, for your X, 0 to infinity, your X is defined as just X. But if you are on the negative side of the X axis, you're defined as negative X. And of course, we'll look at some other examples over here. So just to kind of show you how, if we had to complete this table, how would you work on this? So let's say if I use -2, -1 for my X values, and then 0, 1, and 2. The upper half here, I would use this as my function. And for the bottom half, I would use this as my function. So to calculate that first one, I would do negative of -2, which would give me +2. I would do negative of -1, which would again give me +1. But for the second half, or the positive side of our graph, I would do just y of 0, 1, 2, because you keep the X value as it is, right? And then when we graph it, we would be at 0, 0, 1, 1, 2, 2, and then -1 became +1, -2 became +2. And you can see that graph just basically. What will be, well, first of all, is this a function or not? Yes, it does pass the vertical. All right, what about the domain? What X values are we looking at? Yeah, or real numbers, -infinity to +infinity, and what about the Y values? And what symbol on 0? Bracket. Yeah, very good. Yep. Feel okay? All righty. And then you will see, we're going to change this up a bit and see what these guys look like. So let me see if we have something. Okay, we do have something similar. Yeah, so let's do these examples from iMath. So let's do this guy with absolute value, and this one is y equals negative 10x. And you will see there's a negative on the outside of the absolute value, so that's actually going to change what this graph is gonna look like. You've given the x values over here, and we have to find their y values. So let's start with negative on the outside, 10x, and our first x value was 0, so what will this value come out to be for y? Yeah, because 10 times 0 is 0, absolute value of 0 is 0, 0 does not really take a negative sign, so it just becomes 0. Okay, then we have again negative on the outside, 10 times x, x is now negative 1. So what will he come out to be? Is it negative 10? Let's check. So inside the parentheses, or sorry, no, inside the absolute value, we're multiplying 10 with negative 1, which will make it negative 10. But absolute value itself makes a number positive. But remember, we have this negative in front, so no matter what, your answers will always end up becoming negative. Okay, that was the second number. Again, negative on the outside, 10 times negative 2. And what does he become? Yeah, logic tells us it should become negative 20. So let's check that math again. 10 times negative 2 is negative 20. Absolute value of negative 20 will make it positive. But again, we have that negative sign in the front. So he stays there. All right, last two. What will these guys give us?
Okay, just as a guess, because the absolute value has a negative sign in front of it, it's gonna be another negative 10.
Yeah.
Even though the one is positive.
Yeah, very nice, perfect. So this negative in the front is what's making all the numbers negative except that 0, right? So again, 10 times 1 is 10, but that negative in the front will still make it negative. This guy here would be 10 times 2 is 20, but again, that negative makes it negative. You guys know what the graph would look like for this? Open up, open down, open right, open left. Because of that negative in front of the absolute. Alrighty, let's check this math. Good. Size, A, B, C, or D. Can we eliminate any of them? Which ones? Yeah, the ones opening upwards are going to be eliminated, so you're really just choosing between A and C. Okay, so this is what graph A looks like. Kind of narrow, right? That V shape. And then this is what graph C looks like. So which one would you go for between A and C? And you know what? The best thing to do is open the graph and see which of these ordered pairs would match. The A. Now 0, 0 is not going to be helpful because both graphs start at 0, 0. So you got to find some of the other points. So I'd probably do these two. So negative 1. Now you can see this is ending at negative 10, right? So that tells you these guys are going to be in 2. So your negative positive 1 is here. These guys would be negative positive 2. So you can use those markers. You can see this is ending at negative 20. So this definitely tells me negative 2 and 20 is here. Sorry. This guy here would be positive 2 and negative 20. If you wanted to do the 10s, that's going to be here. So actually the 2s might be a better number to instead of 4s. So yeah, it's going to be option A. And the other thing, which again was something we will be talking about later on, is that 10 actually tells you, remember I was telling Angel about that, how the coefficient in front kind of tells you about the stretching and shrinking. So that's actually what's happening with that 10. It's making your graph stretch, which is actually making it look narrow. So that's why that V shape is much narrower for this guy. So that's gonna be option A. So let's check A, he looks good. Okay, now they wanna know domain and range. So, like me, people, what do you think the domain for this function should be? Yeah, perfect. And I like that this graph is actually giving you the arrow, so you know that these lines are gonna keep growing. So as this arm is going down, it's also making its way to the right, which means this is going towards positive infinity. And of course, since it's headed downwards, that means you're going towards negative infinity on the y-axis. Same thing with this arm over here, as he's going down, he's also making his way to the left. So that means you are getting closer to negative infinity on the x-axis, and same thing, since it's headed down, you are going towards negative infinity on the y-axis. So domain is all real numbers, negative to positive infinity. What would you say about the range? And this time I do want you to give me the interval notation in the correct order, so I know you guys are on track. How would you write your range for this one?
0 with 0 in the bracket.
Perfect, yeah, so again, kind of think of, I'm coming from the negative side, I'm coming from negative infinity, and the highest I'm going to reach is 0. And since 0 is included in our value, our ordered pairs, you're gonna put a bracket. Perfect, very nice, Menji. Alrighty, so let's type this in. Get rid of you. Plug it in, so we are doing negative infinity to positive infinity. Check that. And then range, as we were told, negative infinity to 0, and then close it on. Yeah. Well, is this guy a function? Yes. Yeah. Okay, very nice. So again, you can see this is defined over two separate parts of the x-axis. They're telling you if your x value is greater than 1, use the upper function. If the x value is including 1 and less than 1, use the bottom function. So this one I would definitely recommend to create an x and y table. So we can do numbers larger than 1. So technically it's telling you x greater than 1, right? But I am actually going to use 1 because I want to know what happens right at 1 between the two pieces. Are they touching? Are they not touching? So I am going to use 1, but I'm also going to use numbers larger. Then we'll do the other side, which was x minus 4, and this was for x values less than or equal to. Now, this one specifically is asking us to include the 1, so of course you do want to use 1 here, and then anything smaller than 1. So that's going to be 0, maybe negative 1. You know, you can use more numbers if you wanted, but we just want to know what's happening between the two pieces. Now, looking at the graphs, we can obviously tell they don't seem to be touching, right? The two arms. But again, we just want to see which one it's going to be. So plug this into your function here, and you've seen I've written each of the pieces out. So if I do 1 plus 1, because my x is, 1, so 1 plus 1 will give me 2. So that's an ordered pair of 1, 2. 2 plus 1 will be 3. So my x value was 2. My y value came up to be 3. This one here, my x value is 3. So that's 3 plus 1, which is 4. So that becomes the ordered pair 3. So that was the first half. The second half is x minus 4 as our function. So that is 1 minus 4, which is negative 3. So that's an ordered pair of 1, negative 3. My next x value was 0. So 0 minus 4 is negative 4. That becomes 0, negative 4. And then the last one was negative 1 minus 4, which is what? Negative 5. So that becomes negative 1, negative 5 ordered. So you will notice this guy here, both have the same X values, but our Y values did not come out to be the same. So we know there's a disconnect between the two graphs. Now, if you were to just graph this, and I'm gonna do a rough sketch here, just to show you. 1, 2, 3. Then this is a very rough sketch, guys. I just want to give you an idea of what the graph looks like. So we did +1, +2, but remember here, the 1 was not included. So when you actually graph this, you want to graph it with an open circle. Because that piece, that 1, was not part of that part of the function. So that's why we're leaving it as an open circle. And then you had 2, 3, 3, 4. So this is actually going to be a straight line, going this way. And this was that piece for y equals x plus 1. The second half started at 1, -4. So you're actually at 1, -4. And here the 1 was included. So I am actually going to use a closed circle for this guy. And then the next one, we had 0, -4, -1, -5. So you can see this is a line that's going down this way. So which graph would you say kind of satisfies our rough sketch here? D? It's got to be B or D, right? So here you will see why B does not work is because you had the open circle in the wrong place, right? This is a closed circle here, open here, which should be reversed. And that is only possible in graph D because you do have the open circle on the top, closed on the bottom. So very minute difference, but you do have to watch out for that. So let's pick D. Save, he looks good, and now we need to answer for our domain and range. What do you think the domain for this function should be? Is it negative to positive infinity?
What if the circles close it off?
So think about this, and this is kind of where we gotta let our imagination fly a little. So imagine if that top half came and connected with the bottom half, so you kind of like vertically squished it. Will the two circles go on top of each other? Yes, so technically, you're not skipping any X values, right? If we squish it vertically, the top half is going to coincide right on top of the bottom half. So as far as the X values go, you're actually using all the X numbers. You're using the +1 over here, but you skip it over here, but it's technically still being used. So yeah, your domain is going to be all real numbers. So what about the range then?
So, negative infinity, comma, -2 bracket, and then that little U thing, I don't know what it's called.
Union.
Yeah, that, and then comma, and then it would be 2, comma, infinity. Well, bracket 2, comma, click.
Okay, so you were coming from negative infinity and you stopped where?
-2. That's where the graph,
It's not negative.
I mean, 2, excuse me. Shoot, what, I can't see,
That's 0, 0.
that's 4, right?
What is this here?
That's -4. I can't see. 3, -3, there you go. And then it'd be bracket.
And it's actually in our ordered pair here.
I got it, sorry.
That's okay. You will be able to see it better hopefully when you guys are doing the homework itself, right? So you are actually ending at -3 on the bottom half. And then you can see all of these Y values are not being used. So you do have to skip those. Pick right back up here, which happens to pick up back at 2, +2, and then of course you're headed to positive. And again, those arrows are kind of indicating that those arms are going to keep going. So it just takes a little bit of maybe zooming in and being able to see your graph better. But yeah, that's what your range is going to be. And since you do have the gap on the y-axis, guys, you will need to use the union symbol. So you're going from negative infinity to -3 with the bracket. Union, pick up the bracket again, and then you're going from 2 to positive infinity. That's incorrect. What did I do? Why is that incorrect?
I think the bracket
Oh, not on the 2, sorry.
is open.
Yeah, because that's an open circle, so this needs to be parentheses. Sorry, my bad. Suppose change him to a parenthesis and it should be, yes, good on that. Yes. So we'll pick up from here, guys. I do want to show you a couple more piecewise functions, so that you can get a little better sense of what these graphs will look like. But we're kind of almost done with, 2.2. We just have to talk about piecewise functions and then the greatest integer function, and then we'll be done with this. So let's pick up from another example of piecewise functions and we'll go from there. So at this point, what is today, Tuesday? So by Thursday, I definitely want you guys finished with section 2.1 homework and halfway through section 2.2 homework. All right, we're not gonna repeat what happened for exam 1. All right, everyone, have a wonderful afternoon and I will see you guys on Thursday. And again, you need to make up your attendance, see the email I sent out, okay?
But they don't spin.
On Zoom, did you guys have any
I'm
questions?
so happy.
Are we okay?
Did you bring your bike?
No, not today, I didn't.
Did you see the Zeal 6 part got taken?
If not,
Oh,
I'll see
yeah,
you guys on-
Yeah,
I did, yeah, I did see it. That was pretty sweet. You know who that is?
I don't know.